Hi, I'm Chris Cooper.
And I'm Jennifer Harris, and today we're going to be talking about the process of digitizing physical objects into 3D models. So the digitization process, in a nutshell, is taking a physical object, like my little squishy palm tree I have here, okay, and it is scanning this object and then creating a digital model using it. Now, once you have a digital model, you can use that model, you can replicate it in different software, you can alter it, do whatever you need to do with it. And if you choose to, again, you can ultimately replicate it on a 3D printer. In our case, we replicated it here in plastic in this nice neon yellow.
There are several different methods for creating a 3D model. There is the interpolation of photographs. Software that does this has the advantage of creating a model with realistic color, but it doesn't always give you realistic contours. There is 3D production using a stylus to define actual physical points on an object. And there's also the use of lasers to define contours. Both of these have the advantage of giving you very accurate contoured shapes, but they don't provide color. One of the nice things about the NextEngine 3D scanner, which is the scanner that we use in the Makerspace, is that it combines the use of lasers to create realistic topology and also photographs to give you realistic color.
So what we're going to talk about now is a little bit about what kind of objects can be scanned successfully. So there are certain objects that have properties which will be difficult for your general scanner to be able to pick up, and there are some objects that are built in such a way that their properties will allow the digitization process easily. So Chris is going to tell us a little bit more about what those properties are.
So one thing to look for is objects that are fairly uniform in tone. One of the advantages that this palm tree has is that the green and the brown don't contrast very much in terms of their darkness and lightness. If you had an object like this with strong black and strong white features, the scanner may only be able to pick up the black or white. Another thing that you want to look for is objects that are not reflective in nature. This object has a reflective necklace, and that is something else that can confuse the scanner. Another thing that you want to look for is objects that are solid and non-translucent, so our palm tree doesn't let light through in any way. Another issue that this little fellow has is that many of the beads here are translucent and the scanner will have difficulty picking those up. Additionally, you want to look for objects that are not fuzzy on their exterior. Things like stuffed animals don't work very well. You also want something that is rigid. You have to rotate the object several times in order to get a good scan, and you don't want it to move during that process. When setting up a scan, you need to take several things into consideration. One is whether or not you want to have a 360-degree scan of your object or just a facing scan. You get to control the number of points of rotation involved in the scan making process. In this case, we've set it up to a 360-degree scan with 8 stops. After you've determined the nature of your scan, you can tell the software if you want it to be in high definition, standard definition, or a quick scan. You also need to consider whether or not your object is dark, a neutral color, or light. In this case, our object combines dark and light features, so neutral is the best choice. Next, you need to figure out how far away from the scanner the object needs to sit in order to be fully photographed. In this case, we've got the macro option selected because the object is small, it can sit close to the scanner. The device will then estimate times and the amount of memory that are needed in order to create the scan. In this case, it's going to take 27 minutes. Once our settings are complete, we're going to position our object on the scanner. When we place our object on the scan bed, we will use the armature to help keep the object stable. So that it doesn't move while rotating. We can see over here that we have set the object up so that it fills the scan area and also so that it is in focus. You can move the object back and forth to try to get the best alignment with the scanner. Once the object is positioned, you can use the cursor to select the area that the object resides in, and that will help to make the scan more efficient. We just click Start. During the scanning process, the 3D scanner will bounce the laser beam off of the object that we're scanning, and it measures the amount of time it takes the laser to go from the machine and back, and it uses that timing to determine the contours of the object. After the contours have been determined, the next engine scanner takes a photograph of the object and maps that photo to the contours. Alright, once your first scan is completed, it's necessary to reposition your model in order to capture any areas that were missed during the first scan. So this happens a lot with the top and bottom of your model that will not be present in your original version. It's essential not to move any portion of the object when you are moving it to a different position, or else the software won't be able to reconcile the two models. You don't change any of the settings with your scanner, leave everything else exactly the same, and run the second scan. This process can be repeated several times if you discover that there are areas that are missed in any of the intervening scans. After you've completed your scan, it's going to be necessary to remove any material that appears in your 3D object that is part of the scan bed and that you don't want to have appear in your 3D model. We do that in the trim mode of the software. We're able to highlight any of the objects that we want to remove. And click the trim button to cut them out of the 3D model. It's possible to zoom in on your object and to rotate it to get the best angle to remove the unwanted material. Once your 3D scans are cleaned up, it's going to be necessary to align your models. This is done by selecting points that are in common on the two scans, and you're given a red, yellow, and blue point to define. You want to look for areas that stand out and that are common to both scans. Then we'll ask the software to align the models. We now have one digital file that combines aspects of both of our scans, hopefully filling in all the holes. The fill feature can be used to clean up any holes that remain in your model. So here we have one of the feet that wasn't properly scanned. The software has detected a hole there. We can select that and then use the fill feature to fill in the hole. Now you can see the foot area no longer has a hole. There are a number of options for outputting the file once it's completed. This obviously depends upon the application that you want to use the file for. OBJ and STL files are particularly useful for our purposes because they'll allow for 3D printing. And this will allow us to open the file, in our 3D printing software, and be ready to make a physical copy.
Alright, so thank you for watching our video on digitization. Hope that you found this to be useful and helpful when you go to investigate equipment and software that you can use for digitizing physical objects into 3D models. If you have additional questions for us, please feel free to email us at j.harris@snhu.edu, or Chris is available at c.cooper@snhu.edu. You can also visit our website at libguides.snhu.edu/makerspace for more information. So good luck.